Okay, this video I will introduce two methods for solving quadratic inequality. The first method is using graphs, and this is quicker, but it might be a little bit challenging to understand for some people. So first try to understand this one. If it works, that's great, because then you'll be able to solve these inequalities much faster. Actually, faster means less error, less mistakes, so that's good. The other method is somewhat slower, but it's easier to understand what's going on. Okay, so let me try to explain both of them. Let's explain using an example here. Say, solve the inequality x squared minus 4x plus 3 bigger than 0. In whatever method you use, you always have to find the zeros, or the zeros are also called the roots. In other words, you make sure the right side is bigger than 0 or less than 0 or whatever, and then you change the inequality as equality, okay, just like that. And then you can solve this using the quadratic formula or by factoring. Here it's easy to factor, so I'm just going to factor. But of course you can use the quadratic formula and you will get exactly 3 and 1. Okay, so up till this point the two methods I'm explaining is exactly the same. Now how do you solve this by using graphs? Well, what you do is you first draw the graph using the zeros and also this y-intercept. See, if you have a quadratic equation, then if you have the two x-intercepts, 1 and 3, and if you also have the y-intercept, which is the value of c, and that's also, let's say, that's also 3, then the graph of the parabola has to go through all of these points, because those are the points. Intercepts are points where the graph passes through the y-axis or x-axis. So these are the three intercepts. So it must pass through it. So it must pass through it here, pass through here. And remember, somewhere between the two roots, there's the vertex. So it must have some vertex exactly at the midpoint, and then it should come back up there. So you draw the graph. And so graphing is not that hard. It's just draw the graph. And here's the really quick way to understand what the solution is. The quick way to see the solution is, see, we're looking for places where this left side is bigger than 0. In other words, I want to know when the graph is above the x-axis. So I would say that the bigger than 0 means above x-axis, and less than 0 would mean below the x-axis, right? So since it's above the x-axis, the part of the graph that's above the x-axis would be this part and also this part, and you're saying that the two outside intervals are the solutions. So we know that x is less than 1 or x is greater than 3 are the two possible solutions. Okay. Now, when you have a strict inequality, you should also have strict inequality here. If there was an equality there, then you would also have equality here as well. But since we have strict inequality, we go with the strict inequality. Now, often you'll be asked to write this in interval notation. In interval notation, because the first interval starts from negative infinity and it stops at 1, and 1 is not included, so you use a parenthesis. Infinities are never included as a number, so it's a parenthesis. Here the second interval starts at 3 and goes up till infinity. Again, both endpoints are not included, and then you would put unions. If you have more than one interval, you put union. Now, if this had the equal sign, then the solutions will have equal sign, and in those cases these would become brackets. Okay, but here It's a strict inequality, so that's the solution. All right. Now the second method, using the number line, what you do is, let's work with the same inequality so you can compare the two methods. Well, you still have to find the roots. So since I've already shown you how to do it, here are the roots, 3 and 1. And what you want to do is you first have to put the numbers on the number line. So 3 and 1 are put on the number line. And then you have to choose a test point for each interval. So what you do is from the first interval, so this is how you think. Because we put 1 and 3 on the number line, these two numbers divide the entire number line into 3 intervals. The first interval, second interval, and third interval. And from each of these intervals, what you need to do is you have to pick a number, any number. Pick a number, any number. You're trying to work with these numbers, so it's easier if you choose numbers that are small. So 0 would be the obvious choice before 1. 2 is like the only integer between 1 and 3. 4 is the smallest integer after 3. So these are the 3 test points I picked. And what you do is, once you pick the test points, you want to plug in these numbers into the inequality to see whether it works or not. So I plug in 0. So I'm plugging in 0 in here. And 0 squared is 0. 4 times 0 is 0. So you end up with 3 bigger than 0, which is actually true, right? But if you plugged in the second test point, which is 2, and you plug it in here and here, you get actually 2 squared is 4. 4 minus 8 is negative 4 plus 3. You get negative 1 bigger than 0. And that's wrong. It's not true, right? And then you also do that again for 4. You plug in 4, and this time you get 3 bigger than 0. So you know that this is good, this is good, this is no good. And once you have figured out that this is good and this is good and this is no good, then the interval that's containing the good parts are the solutions. So the first interval would be from negative infinity up till 1. This entire interval is good. It's like testing water in a water treatment facility. You have a body of water, you just need a drop of water to send it to the lab to see if the water is clean enough to eat or something, okay? All right, and then over here, this interval starts at 3, it goes up till infinity. Now, make sure that your endpoints are indeed the zeros you found. See, the zeros of this was 1 and 3, right? So endpoints are 1 and 3, so that's good. Okay, if these numbers don't appear in your final answer, then something's not right. Okay, so that's how you do this. Let me do another question, and this time let's make something slightly more complicated by putting minus in front. So let's say you have negative x squared plus 5x and then minus 6. Okay, and then it's, let's say, bigger or equal to 0. Okay, so this one, if you use the quadratic formula, you get x equals to negative 5 plus or minus square root. You get 5 squared minus 4 times a is negative 1, c is negative 6, over 2 times negative 1. Be careful, a is negative 1, not just 1. And that gives you negative 5 plus or minus square root. Negative times negative times negative is still negative, right? So 5 squared is 25. 4 times 6 is 24, but because we said it's negative, it's 25 minus 24 over 2 times negative 1 is negative 2. And this gives you 25 minus 24 is 1, and square root of 1 is just 1, right? So you have negative 5 plus or minus 1 over negative 2. And the two solutions are negative 5 plus 1 over 2 and negative 5 minus 1 over 2. What's that? Negative 5 plus 1 is negative 4. Negative 4 divided by 2 is negative it's negative, oh, this is negative 2, sorry. It's negative 4 divided by negative 2, which is positive 2. And this is negative 6 divided by negative 2, which is positive 3. So you have the two solutions, 2 and 3. Now, because a is negative, it's an upside down parabola, right? Or you can also just use the fact that negative 6 is the y-intercept, and for a parabola to pass through these 3 points, it must be upside down, right? So you get this upside down parabola, and because you're looking for the place where it's greater or equal to 0, the portion of the graph which is bigger or equal to 0 would be above the x-axis, which is this much. So it's between 2 and 3. And because this is including the equality here, the solution should be between 2 and 3. And in terms of interval notation, it'll be 2, 3 with closed brackets. And if you don't like this graph method because it's too confusing, then we can also do the number line method. But this is slightly harder this time because if you have 2 and 3, unfortunately the only test point you can use is 2.5. So it sucks because you have to plug in 2.5 squared, so it's a lot of work. So I'm not going to show you this work, but if you actually did the work, you'll see that these two are no good this time, but if you plug in 2.5, it's good, so that this is the middle interval is the one that works. And again, you get the same answer, 2, 3. It's the middle interval, and that's the answer to this inequality.